Good morning, guys. I just got an email titled "What on earth are radians and why do I need to use them?" I thought I might do a quick lesson on what radians are. My response initially was go and have a look at Sal Khan's video. That wasn't me being lazy, so I apologise to that person. But it's just I really respect that particular lesson, or all of Sal's lessons. But certainly that lesson's a great one to have a look at. I really encourage you to do so. Probably won't, do his lesson justice, but I'll certainly give it a crack. So the first thing I thought I might do is look at just briefly degrees and the background of degrees. I think that's often an important thing to do. To be honest with you, no one really knows where degrees came from, where they originated from. There are some theories, of course, and I encourage you to go and have a look at some of the theories on Wiki or YouTube or wherever. But one of the main theories is coming back from the old ancient calendar system, on the belief that there were 360 days in a year. So particularly the Persians and the Mayans. I think the Mayans, from memory, were 360 days plus 5 bad days or something like that. But it was basically 360 days. So I guess, if you think about, your starting point on the 1st of January or wherever they thought it was, all the way to the last day of the year, that was 360 days for a revolution of a year. So that became 360 degrees for a revolution for a circle. So that was their main thought. And look, I've got no idea if that's true or that is one theory. And so it's a pretty good theory if you sort of think about it. The second theory comes from, I think it was the Babylonians, where they used a circle. Now, the Babylonians loved equilateral triangles. I mean, come on, let's be honest, who doesn't? They're perfect in every way, equal sides, equal angles, all that sort of jazz. So what apparently they did, they split the circle up into lots of different equilateral triangles, obviously of all the same size. And so what they figured out when they did that, and obviously they all have 60-degree angles, and if there are 6 of them, we have 6 lots of 60 degrees, which makes that magical 360 degrees, which is, it's another possible solution to why they came up with degrees. Okay, 360 degrees in a circle. But anyway, either way, there are 360 degrees in a circle when we talk about the degree system. So remember, the degrees is a measurement of angle or turn in one full revolution. In most of our cases in class and that sort of thing, for the most part, we tend to use degrees. As a measurement of geometry. Although when you get into more advanced mathematics, we start looking at what we call radians, and that's what we'll be looking at today, where radians come from. And certainly radians are much easier to use for advanced mathematics, and certainly for geometry, and it makes a bit more sense to use them when you see how easy some of the calculations are, particularly for areas and arc lengths and that type of thing. So, where do radians come from? Where they originate from? So, what I thought I might do is, I've previously drawn up a unit circle. Well, it's actually not a unit circle. It's a 5-unit circle, should I say? So, what I've done here is I've created a circle and I've used a radius of 5 units. Now, it doesn't matter what radius you use. In fact, when you're looking at the general solution or rule for it, we actually just use the value of r as the radius. Now, what they did to come up with this sort of general rule, they thought, well, what we might do is we're going to look at just one part of a circle. Can you remember what that's called? Hopefully you remember it's called a sector. And what we're going to look at is a sector that has an arc length with the same distance as the radius. So that means, in this case, if I've got a radius of 5 units, they want us to look at an arc length also of length 5 units. It's kind of like an equilateral triangle in a way. I guess, except one of the sides is curved. So obviously here I've got this nice little sector with 5 units on all sides. Now they said in that case, if we're going to have a perfect little sector like this, we're going to say that this has, instead of measuring as an angle in degrees, they're going to say it's got a turn of 1 radius. Okay, 1 radius. And what they're going to do, we're going to split and see how many radiuses, or complete radiuses, go into this full circle to make up the circumference. So instead of measuring, I guess, the turn in angles, in degrees, they're measuring the turn, this turn here, in how many radiuses fit into this circle. So for that one sector, there'd be 1 radius. Now, obviously, if I look at this bit here, that becomes 2 radiuses, or 2 radiuses, or 2 radii, or 2 radii. Okay. Now this is the other thing. When they're looking at that terminology, you know, 1 radius is fine, but when you can't do 2 radiuses, okay, there's lots of ways of saying it. Radiuses with apostrophe, but that doesn't really work either. It could be radii. Could be radii. It's a bit confusing. So instead of using the word radiuses, what they decided to use is the term radians. So 1 radian, 2 radians. Very simple. Okay, so when you talk about a circle that has 1 radian, or a sector with 1 radian, it simply means that the lengths are all the same size, because the arc length has an arc length that's the same as the radius. You know, if I drew a little sector down here and said that had a value of 2 radians there, well, if that, let's say that was 3 and that was 3, well, that would mean that the arc length, okay, would be 6, because it's twice the radius. All right, so it's just a different way to measure the turn of that sector or that circle. Instead of using degrees, we use radians. Now, often we say that, not often we say, when we're measuring degrees, we use it, that little circle. When we're measuring radians, we use a little c, okay, or 2 radians, we 2 little c. Now, often I write 1 radian, or I write 1 rad, or 2 rad. But certainly, if you want to use that, that's okay, but just don't muck it up with a degree symbol, because they are quite similar. Now, the other thing that's quite important to note is, if we look at 360 degrees as a point of revolution, how many radians would be in a full circle? Now, you can see for a half a circle, I've got 1 radian here, 2 radians, 3 radians, and there's a little bit left over. Okay, just a little bit. So I wonder how much that's going to be. Well, let's have a look at the circumference the whole way around that circle, because that's going to tell me how many radiuses there are. So the formula for the radius of the circumference of a circle, we know, is 2 pi r, or in other words, 2 pi radius, or 2 pi radians, which means that 2 pi radians is equal to 360 degrees, which means half of that, which would just be half of 2 pi is pi radians, will be 180 degrees, which means if I'm asking how many radians there are here, okay, for 180 degrees, well, pi equals 3.14 radians, doesn't it? Well, 3.14. Therefore, if I look at how many radiuses, there's 1, 2, 3. This part must be 0.14. Okay, and that's quite interesting. All right, it's quite interesting because it helps us later on with conversions between degrees and between radians, which I'll show you shortly. And that works out quite nicely. And the other thing here, I've got these angles here and actually got lengths. So here we've got 5, 5, and 5, which makes those radiuses there, those 3 radiuses, and I've got 0.71. If you add all those values together, we're going to get 15.71 centimeters for this particular example. Now, if I wanted to do a quick way, and I said, well, okay, well, if there's 3.14 or pi, if I've got pi radians there, lots of 5 radiuses, that's going to give me approximately 15.71 centimeters. That works out to be exactly the same. So I actually did that through measuring through GeoGebra, and that works out. And actually that leads into looking at the rule for the arc length of a circle, which if I want to find out what arc length is, I just need to figure out, if I know how many radiuses there are, which is going to be your radians, or theta, let's call it, times that by what the radius is, that becomes a really easy formula to remember. So if there are 2 radians, should I say, that's my length, 2 radians, or my angle length, then it's just 2 times your radius, which 2 times 5 is 10, which we did that earlier on of this question. Okay, so you can work out quite quickly what the arc length is, which is much easier. If you remember back to degrees, it's like theta over 360 times 2 pi r. That can get, you know, quite lengthy and quite challenging, where this formula, it's really straightforward, and we'll be doing another lesson later on that. My other thing I'm going to just say quickly is just looking at the conversions between them. That's what I think people can be quite interested. If we can remember that 2 pi radians equals 360 degrees, which then makes pi radians equals 180 degrees, this conversion, or that conversion there, can help us with all conversions. If I want to know what 1 radian equals to, well, let's just divide that by pi. Divide that by pi. That equals 180 over pi. That's the conversions for radians. So if I want to find out what 2 radians is, okay, we simply times this by 2. Likewise, if I want to find out what 1 degree is, okay, we know that pi equals 180 degrees. Well, just divide that by 180, divide that by 180, we get pi over 180, which is great because, like, for example, if I've got 90 degrees, we just times it by 90. We get 90 pi over 180, which simplifies to pi over 2. So we can go through these conversions really easily from this main fact that 2 pi equals 360 and pi equals 180. Look, I'm not going to go through that whole conversions. I'll do that for our next lesson. Then after that, we'll do arc length, then we'll do area. This is basically just a quick rundown on what radians are, what we use them for, and that's basically for geometry of circles, but mostly graphs within trigonometry, because graphs in trigonometry, a lot of them are made up of part circles, but it is quite easy for us, much easier in geometry to use radians than it is to use degrees. Just for your information, guys, if you are using your calculator for calculations, just make sure in the top part of your calculator, that's your, if you got your calculator like this, for example, your little screen is there. At the top here, there'll either be a little D or it might be a little R. Obviously, R would be your radians and D would be your degrees. And often you get to that from your setup mode, your shift mode, and then you can go into your degrees or radians. So depending on what you're using, often your calculator will be using degrees, and often that's for trigonometry. For most purposes, we use that for basic trigonometry. If your question asks you about radians and you do calculation radians, you need to make sure you change your calculator. Alright guys, I hope this gave a bit more of an insight into what radians are and the differences between radians and degrees. Yeah, hopefully if you know, go and have a look at some of the other tutorials on YouTube, particularly from Sal Khan, because I think he explains it quite well and probably better than I do, but certainly that might be useful. And then look to see my next couple of lessons on calculations with radians. Have a great day, guys.